Hello young explorers. In your earlier classes, you have learnt about various elements. You have seen that elements can be classified as metals or non-metals on the basis of their properties. Look what I have here, symbols of elements. You can also make them easily, best out of waste. See, I have utilized bottle caps to prepare this game. And here I have a Venn diagram with two overlapping circles. In this circle I have written metals, and in this circle you can see I have written non-metals. So, all you have to do is recognize the symbols of the elements when I call out their names and just quickly place them in respective circles. So, let us recognize the symbol of sodium, where it is. Yes, Na is sodium. So, let us place it here. Next, aluminium, Al. It is again a metal, place it over here. Boron, it is a metal, we place it here. Carbon, what is carbon? Carbon is a non-metal, so it goes in this circle. Next, oxygen, yes children, what is oxygen? Again a non-metal, so we place it over here. And this way the game can go on, and you will be very easily able to know the symbols of the metals and non-metals. Yes, now these are all metals, and you know that fascination of humans with metals began with prehistoric man, who began using range of metals, advancing from stone age to copper age and then finally to iron age. And you also know that advancement of civilization from time to time has taken place with discovery and application of metals. So, today we are going to study chapter metals and non-metals of class 10th. To begin with, think of some uses of metals and non-metals in your daily life and try to group them into metals and non-metals. What properties will you think of while categorizing elements into metals and non-metals? And yes, do not forget to see this word metalloids. We will talk about this later. The easiest way to start grouping is comparing their physical properties, and you have done this in your previous classes. Let us quickly revise them by playing a quiz. Are you ready? Okay, so here is your quiz. Look, here I have copper rings. If you look at the outer surface, how do they appear? Little dull. And now look at its inner surface. This is not dull. So, quiz question number 1. Metals in their pure state have a shining surface. What is this property called? I am sure many of you have guessed it right. Yes, it is metallic luster. And now quiz question 2. Here I have aluminium foil. What is this ability of metal to be beaten into sheets called? Come on, hurry up. Yes, you have guessed it right. It is malleability. And it will be interesting to find out what are Olympic medals really made of. Quiz question number 3. If I tell you wire of about 2 kilometers length can be drawn from just 1 gram of gold, which property I am talking about? Correct, ductility. Now, coming to quiz question 4. Have you heard this ringing sound of bell in school? Which is the property of metal I am talking about here? Absolutely correct. It is sonorous. And now, quiz question number 5. Look at this picture on your screen. Cooking vessels are made of metals. Do you know why? Yes, guess? Of course, you are correct. They are good conductors of heat and have high melting point. You know that the best conductors of heat are silver and copper, but obviously we cannot use them as cooking vessels. And lead and mercury are comparatively poor conductors of heat. Here, I must remind you that your experiences and observations of real life situations and your previous knowledge helps a great deal in construction of knowledge. And I am sure you all are very observant. Here is a task for you. Make your own electric circuit and place small piece of metals or non-metals or some other material one by one to be tested in the circuit. You know this circuit you have already made in your earlier classes. I am sure you will be able to make on your own. And then note your observations. This way you will compile a list of elements which help the bulb to glow in the circuit. Discuss with your friends. If you have doubts, ask your teacher as well. This way, when you relate learning to your immediate environment, you become lifelong learners. But remember, elements cannot be grouped on the basis of their physical properties alone, as there are many exceptions. You want to know what the exceptions are? Okay. The first exception is that all metals exist as solids at room temperature, except one. Can you name it? Yes, correct. It's mercury. And you must have seen that in thermometer, the mercury which is used, it goes up and down, it expands and contracts with change of temperature. I am sure you will always remember this. Okay. You know that metals generally have high melting points, but gallium and cesium, they have very low melting points. These two metals melt if you keep them on your palm. And what about this piece of coal and sulfur powder here? Do they have luster? Their appearance is so dull. So, that is why they are classified as non-metals. Now, listen, iodine is also a non-metal, but it is lustrous. So, remember, there are always exceptions. The non-metals are either solids, as you saw in this case, or gases, except bromine, which is a liquid. Another physical property of metals is hardness. Now, question is, are all the metals hard? There are some alkali metals which are so soft that they can be easily cut with knife. Can you name them? Try finding out the answer. Yes, lithium, sodium and potassium. And also remember, they have low densities and low melting points as well. Elements can be more clearly classified as metals and non-metals on the basis of their chemical properties. Can you recall from chapter 1 that magnesium ribbon burns in air with dazzling white flame? Now, it is time for doing a small activity. I have here this white ash which is collected after burning of magnesium ribbon. You have already performed this in chapter 1. And can you recall what this white ash is? Tell me. Yes, it is magnesium oxide. Now, this magnesium oxide, the white ash, I mixed with water and I have stirred it to get this solution. Do you know the formula of this substance formed after mixing magnesium oxide with water? Tell me. Okay, it is magnesium hydroxide. And here I had taken sulfur powder, and you know what I did? I burned this sulfur powder in air. You have done it in your earlier classes too. And this I collected sulfur dioxide and dissolved it in little of water. Now, I have sulfurous acid here, and now these two resultant solutions are ready to be tested, and now we are ready to test the resultant solutions with both red and blue litmus paper. So, let us do it one by one. So, I am adding red litmus paper in both the solutions. And let me also add the blue litmus in both the solution. Can you see some change happening? Okay, so my dear friends, what is the change in color of the litmus paper? Let us see. Magnesium hydroxide has changed red litmus into blue. So, what can we conclude? Yes, correct. Metallic oxides are basic in nature. Observe carefully change in color in case of sulfurous acid. Well, sulfurous acid has turned blue litmus into red. Can you see over here? Yes. So, oxides of non-metals are, can you guess what are they? Yes, they are acidic in nature, correct. Now, after having watched this activity, we can conclude that almost all metals combine with oxygen to form metal oxides. Now, let us further explore what happens when metals are burnt in air. Now, recall oxidation reduction reaction which you have done in chapter 1. When copper is heated in air, it combines with oxygen to form copper oxide. Remember what was the color of that oxide? Yes, it had turned black. You can see the reaction on the screen. Similarly, what will be the chemical equation when aluminium reacts with oxygen? And yes, remember to write balanced equation. Try writing. I am sure you can match your answer from the screen. We have learnt that metal oxides are basic in nature, but some metal oxides such as aluminium oxide and zinc oxide show both acidic as well as basic behavior. You know why? Because aluminium oxide reacts with acids to give salt and water. And what is the salt? Aluminium chloride. Yes, along with water. So, you can see the reaction on the screen. Al2O3 plus 6 HCl gives 2 AlCl3 plus 3 H2O. And this aluminium oxide also reacts with bases to give salt and water. Look at the reaction on the screen. Such metal oxides which react with both acids as well as bases to produce salt and water, they are called amphoteric oxides. Remember this word? Amphoteric. Yes, they are called amphoteric oxides. Another important chemical property of metal oxide is that most metal oxides are insoluble in water. Go ahead and why don't you find out some examples? But again there are exceptions here. Sodium oxide and potassium oxide, they dissolve in water to produce alkalis, that is NaOH and KOH. Another thing that may come to your mind is that do all metals react with oxygen at same rate? Think and find out. Do a little bit of research. I hear, I forget. I see, I remember. And I do, I understand. Going by this principle, you must engage, explore the unknown, seek explanations, analyze your data, and then evaluate your findings. So, why don't you find out why potassium and sodium are kept immersed in kerosene oil? Have you observed that at ordinary temperature, surfaces of some metals such as magnesium, aluminium, zinc and lead, they get covered with a thin layer of oxide? See, look, here I have magnesium ribbon, and remember why we rubbed it with sandpaper before burning it in air? Well, I am sure you can connect now. And what does this protective oxide layer do? Any guesses? Yes, it prevents the metal from further oxidation. Also look up your books and find out if iron burns in air. And what if iron filings are taken instead of iron? Okay, try to explore, maybe through virtual lab or internet. Your findings may be iron does not burn on heating, but iron filings burn vigorously when sprinkled in flame of the burner. So, further research can be, why is this so? Now, though copper does not burn, but the hot metal gets coated with black colored layer of copper oxide. This you have already learnt. Silver and gold do not at all react with oxygen, even at high temperatures. Go and ask your grandma why gold is so expensive. Also find how anodizing is done on aluminium and how the oxide layer can be dyed easily to give aluminium articles an attractive finish. And my dear young scientists, many questions will come to your mind. What flame color is produced when metal is burnt? How does the metal surface appear after burning? Are the products soluble in water? Always remember, asking questions is one of the most valuable skills a learner can have for learning science. So, never hesitate to ask questions. And children, you may also prepare a portfolio where you can keep all your records. And one of the interesting findings will be of this observation that different metals show different reactivities towards oxygen. Now, in your portfolio, you can keep a record where you have found out from net, or probably a clipping or a picture from a book, or you can even draw a scenery to depict what your findings are. And yes, never forget to tabulate your data. Okay, so prepare your portfolio, as it will not only have your reflection, but will also offer valuable data about what you have learned and how it is important to you in the learning processes. Now, it is time for self-assessment. Here I have wires, and I am sure you are familiar with these wires. See, look here. You have already learnt about the property of metal, that metals are ductile. So, can you see these wires made of copper? Now, you have to find out why these wires are covered with this PVC, polyvinyl chloride. Okay. And you had played a very interesting game in the beginning. Well, remember the Venn diagram game? So, for your portfolio, you have to keep record also. So, what you can do is, the record in the portfolio will look something like this. The metals written in this circle, non-metals written in this circle, and you can also find out some metalloids which you can write over here. And well, you also learnt how to classify elements into metals and non-metals on the basis of their physical properties. So, you can make another Venn diagram of 3 circles where on this part of the circle you will write the physical properties only of metals. Over here you can write the physical properties of non-metals, and the common properties you can write in this portion of the circle, and the properties of the metalloids that you have to go and find out yourself, do a little bit of research as I told you, and write them over here. So, this will be a nice way to keep record in your portfolio. And what else you learnt? Yes, that using scientific conventions you learnt to represent balanced chemical equations. Well, learners, you could plan and conduct experimentations to seek answer to your queries. And you also learnt using scientific conventions to represent balanced chemical equations. So, I hope you will enjoy the learning process.